Hello everyone, my name is Yoshiaki from Federal Institute of Santa Catarina in Brazil, and I'd like to show my solution for this challenge for WinJi gearbox failure detection. Basically, I use two algorithms for this. One is the wired algorithm clustering, and the second one is the LOF, that is the local outlier factor. So this presentation I organize first is the data analysis for the time series. The second part is to use the wired algorithms for finding patterns and filter the data. And the third part is to show the second algorithm, that is the local outlier factor, that really detects the failure or anything not normal for the conditions I adjust. So basically the question I start is how to detect what we don't know the problem, the detection, the failures of the wind turbine. So here is the overview. Basically I use as input here the bearing temperature of the 5 turbines. And after I input this data to the algorithm for the clustering algorithm, this algorithm separate in 12 clusters that you can see here the temperature when some cluster with the same temperature of the turbines and someone with some turbines that are not, they don't have the same temperature in comparison of the other ones. So what I do here is to remove these clusters that I consider that's not good. They have some problem here because the temperature is different from the others. And I use the cluster that have good data to train my second algorithm, the local outlier factor. And that's the training for the normal conditions. So anything new data you input in this local outlier factor that is not equal to the cluster that I consider normal, the algorithm will show me the problem, count the problem here. So that's the way I use to know what we don't know or unknown targets here. So here basically the data input is the bearing temperature, and I compare here the 5 turbines that was in the data set. So basically we have a problem with 3 turbines. One is 109 that relates to these two clusters. Another one is the 120 that is cluster 8. And the cluster 114 that are related to this one, and we have some coincidence and detect at the same time a problem with these two turbines. So I totalize the clusters in the time series for each week here. So each bar here is a total as a total number of the clusters that for each week here. So what I can see here, for example, the cluster 9 that is related to the green one here, that's turbine 114. We can see some events that accumulated this kind of the pattern here that of course will result some problem later. So you can see the same for the cluster 8, that's the red one, and the clusters related to the 2 and the 6 here. That's the 2 and 6 that you can see here and totalize. As I told you, the cluster 5 here, you can see that both are having problem here, the turbine 114 and the 120 here. That's this period. So So what I do here, as I told you, my strategy for training the LOF is to remove these bad clusters. But what I do here is when I try to know the problem for example, the turbine 109 here, I just remove this data, not this data, okay? Because if so what happened here, if you wanna just want to focus on turbine 109, so doesn't matter if the neighbors have some problem. So when I consider this as a normal, so uh, the LOF will only detect the deviation of the turbine 109. Even though the other ones have some problem like this, they will not detect it. So I will show you next slide. So for example, the turbine 114 here, you can see that now here the total anomaly per week, you don't see some accumulation of the problems from the other turbines, only for the turbine 114. So this is the example that the event when the turbine failure here, you can see many events before, some weeks before the problem. And this is the SCADA event here, that's some events that really accumulate. Of course, you have some false false alarms here that some alarms here that the algorithms did not detect, so it's not perfect. But you can really visualize some detections before the problem later here. So the same example you can see in turbine 120. Some problems before, and if you see the SCADA data, you can see some problems, and then the problems happen here. And so the turbine 109 is the same. It's not there are not too much, but you can see 3 months before here the problem, and then you can get it, so the failure here. So that's my results here that I would like to show. In conclusion here, I can see that the disadvantage of this method that is really site specific. You really need to compare, you need multiple turbines data set here to compare the variables between the turbines. This pre-processing clustering is not really easy to do. You need to organize this data in the maybe not arbitrary, but you need to analyze and select by your experience which cluster you consider to remove. So, and also it's difficult to define the number of the cluster. It's best to separate these patterns. The advantage is you don't need a large data set to train. So for every specific failure, so you train in fact the normal condition. So anything different from normal condition, the algorithm will detect. And they also can predict unknown deviations. Usually, if you have some algorithms that try to train failures that was reported before, so some algorithms just training some failures that was training. So that's the difference here. You don't need to find and train every failure pattern. So anything different from normal. So, and final here is these patterns don't need a normalization if you use just the same variable for the same turbines, array of turbines. So that's it, and thank you very much.